This is Pre-Calculus Concept 20C. We've got 6 boxes, so let's get right to it. We're going to talk in the first box here about expanding logarithms. So this is the idea of taking a logarithm of one big quantity and breaking it apart into a lot of components. So these are 3 rules that we've just talked about, and we're going to be using them in this particular direction. To take something that's complicated and break it apart into smaller parts. So we've got our product rule, quotient rule, and power rule, and we'll be using all 3 of these in these problems. Alright, let's look at 2 examples. So I have the log base b of x squared times the square root of y, and the instructions are to expand each logarithm. So when we expand, we want to basically rewrite this so that there are no products, no powers, and no radicals. And so what I end up with is the log base b of x, and instead of x squared, I can use my power rule and put the 2 out in front. And then I have a plus because this is a multiplication problem. I'm going to use the product rule. And then the second half of that product is the log base b of y. And instead of the square root of y, I'm going to put a 1/2 out in front. So we're basically combining some of our rules together to take a single log and break it apart into components. Notice that my final answer has no exponents, no radicals. Okay, down here below is another one. I have log base 5. This time I have, actually let me back up. I have a square root of x, and I'm going to rewrite that as log base 5 of x with a 1/2 out in front. And the other part of this logarithm is on the bottom, so you should recognize that as our quotient rule. I'm going to subtract log base 5 of 25 y to the third, and then realize that the second half of this expression is really another problem where I can simplify or expand further, because that is really the log of a product. So log base 5 of 25 plus the second half of this, which is 3 log base 5 of y. Okay. Ran out of room a little bit there, but that's my final answer. If you want to, you could distribute that negative sign. So another way of writing your answer, log base 5 of x minus log base 5 of 25 minus, when I distribute, 3 log base 5 of y. And then a final thing I can think about is, are any of these able to be simplified, and this ends up being 2. So you could replace that term with the number 2. A good shortcut to remember when you have a fractional expression is that when you break it apart, any of the terms that were in the numerator are going to be positive, and any terms involving what was in the denominator are going to be negative. So in this case I have 1 positive term down here at the bottom and 2 negative terms, right? Alright, let's have you try a couple. So your instructions are to expand each logarithm. Alright. Letter A should have been 4 log base 2 of x plus 1/3 log base 2 of y. Oop, left off my x there, sorry about that. So powers become coefficients, radicals become coefficients, and any product, this is a product, is going to turn into the sum of individual logs. Try letter B. Alright, this one's going to end up being log base 6 of x with a coefficient of 1/3, and then I'm going to have a subtraction problem, log base 6 of 36, and then another minus 4 log base 6 of y. Okay, again, this middle term you can actually simplify. So one step further would be to say 1/3 log base 6 of x minus 2 minus 4 log base 6 of y. Okay, box 4 are the exact same rules, product, quotient, and power rule, but you'll probably notice they're in the backwards order. So we basically want to be able to do the same process backwards. Okay, so if I give two different logarithms and ask you to condense them, then we're doing the exact opposite, and we want to take the smaller logarithms and write it as a single log. So this would be log base 4 of 64. And this is a good time to stop and think about if the final answer can be worked out. Since 4 to the third is 64, this actually has a final answer of 3. Alright, our second example here, there are two logarithms. Notice I have a coefficient in this one, and instead of keeping it there, I'm going to rewrite that as a power. So that's really log of 4x minus 3 squared minus log of x, and when I have the difference of two logs, I can come up with a single logarithm. It's going to be 4x minus 3 squared on the top and x on the bottom. In all these problems, your final answer will be a single logarithm, and what's inside the logarithm will be products and quotients and powers. Alright, let's have you try two. Number one, can you condense this logarithm into a single logarithm? Okay, should be log of the product of 25 and 4, which is 100. And this is one that also works out because common log of 100 is the number 2. Try letter B. Okay, this one is, I'm going to do it in 2 steps. The log of x squared, so that coefficient I'm going to change to an exponent, minus the log of x plus 2. And this is 2 logs that are being subtracted, and so I can condense those into a single log that is a quotient. So x squared over x plus 2 is your final answer. Common log of x squared over x plus 2. Alright, we're going to practice these some in class, but you should be able to both condense an expression with multiple logarithms and also take a single logarithm and expand it into individual logs.